Hello, welcome to today's lesson. This lesson is about practical organic chemistry. This will be our first lesson for the semester. This lesson is going to be about how we can identify unsaturated organic compounds when they are present in a sample. In other words, what are the things that we can do? What reagents can we use in order for us to be able to determine that indeed a sample contains an unsaturated organic compound? I hope you enjoy the lesson. Please leave your comments for clarifications and questions. I'll address them as soon as possible. Thank you. Now let's move on to our lesson for the day. Now let us look at our lesson outline for today. Having looked at the theoretical aspects of organic chemistry, we'll be looking at a general overview of what the practical aspect is about, why the need to study the practical aspect of the organic chemistry, some recommended texts that would help you in this course, then of course go into detail in terms of the content for today. At the end of the presentation, I'll give you some references where you can do further reading or studies on your own. Now, let us look at the overview of what this course is about. This course is to help you make use of the knowledge that you have about identification of functional groups through qualitative analysis. By qualitative, we mean we are interested in whether there is the presence of the functional group or not, and in this case, whether there is alkenes or the presence of alkynes. It isn't concerned with how much or what actual compound is available. Now, with your knowledge of the theoretical aspects and the techniques that will be introduced to you, it is expected to help you have much understanding in order to be able to identify these unsaturated organic compounds. By saying this, I'm in particular referring to the lesson for today. But overall, this course will help you be able to identify various functional groups using methods that are appropriate. This course is also to help you be able to have that basics when it comes to being confident about making analysis and also be able to characterize a wide range of organic compounds. That is, if you are given a set of sample where it contains various organic compounds, you should be able to identify the organic compounds that are present, whether whatever is present, that is the analyte, if it is alkene or an alcohol. By giving you the basics in analysis, or identifying organic compounds, you should be able to identify any of them when given a sample. Here are a list of some recommended texts that you can read on your own in order to be able to grasp these concepts that we're teaching you. Common among these are what I've listed here. You can try buying any of these texts. Identification test for unsaturated compounds. As you are aware, to identify organic compounds is more like a routine task for anybody who wants to do chemistry. In performing chemical analysis, in order to identify the composition of organic compounds that are unknown to you, you need to have a fundamental basis in terms of concept of how experimental organic chemistry is. That is, you need to know the kind of method that might be used in order to establish the identity of a compound. Again, for you to be able to identify an unknown organic compound successfully, you should be able to know which kind of functional group that you are interested in or you are looking for. As chemists, we basically rely on chemical and then spectroscopic techniques in order to be able to tell how, in terms of molecular arrangement, a species exists in a sample. By so doing, this lesson would focus on the chemical methods that can be used in the laboratory in order to identify various aspects of organic chemistry or the various functional groups found in organic chemistry. Like I've initially said, this lesson would concentrate on unsaturated organic compounds. From our theory class, I hope you remember what unsaturated compounds are. If you don't, we'll just do a small recap of what unsaturated organic compounds are. Then we can move to the practical aspects of it. Remember that we said hydrocarbons are compounds made up of hydrogen and carbons. Mostly the carbon bond are single bonds. However, we also stated that you can have more than one bond connecting your carbons. For example, you have C bonding to C. However, we can have C with two bonds. Again, he said the bonds can be more than two, i.e., three. So therefore, when you have a hydrocarbon, having two or three bonds, which would classify as double and triple bonds. Such hydrocarbons are referred to as unsaturated organic compounds. Now, when a hydrocarbon contains a double bond, we refer to such hydrocarbons as alkenes, Alkenes, alkenes. However, if there are three bonds connecting them, we call them alkynes, Alkynes. So, these are the two organic compounds that will be of interest to us. Here are some examples of alkenes and alkynes. Are you able to identify them? Whether it contains double bond or triple bond. Going a step further, can you identify the positions of the double bond and then the triple bond? Again, can you name those compounds? These were all treated in your theory aspect of the organic class. Well done if you are able to name them. If not, please try again. This time around, going over all the rules that we have discussed before. Now, let us look at a few examples of unsaturated hydrocarbons that exist in nature. We can have some alkenes being responsible for the artificial ripening of some fruits, mostly used in industries. Again, in the manufacturing of plastics, organic compounds are very important. You might have been aware of polythene bags around us. All these are made up of organic compounds. Now, the egg crates or cartons that we find in our kitchens, our disposable cups, are products of polystyrene. Are you aware of that? If not, now you do. Now let us look at the various tests for which we can use to identify unsaturated hydrocarbons. There are two major tests that are being used. The first one is Bayer's test. I don't know if the pronunciation is right. Bayer's test. The second one is the bromine test. The bromine test. We are going to look at them individually and then we can compare the two tests. The first test that we are going to look at is the Bayer's test. Now, the principle behind this test is the oxidation of the double bond. Now, this is done by a dilute solution of potassium permanganate being added to the sample. In terms of the reaction, we already know the appearance in terms of color of potassium permanganate being a purple color. Now, When we add the sample or we add the potassium permanganate to the sample, if there is a presence of the unsaturated compound, that is a double bond, we expect that this purple color would have to be decolorized, meaning that the purple color would have to vanish. Vanish to which kind of color? You would say colorless, you would say close to a whitish color. But the general idea is that the purple color of the potassium permanganate would fade. Why is it going to fade? It's going to fade because the double bond would then have been oxidized to form diols or vicinal glycols. That is for the reaction. So in terms of the practical aspect, what are we going to see? We have the sample, we've added our purple colored potassium permanganate solution. Then, if there is presence of the double bond, we realize that the color gradually fades away. What have we said is resulting in this purple color fading? We are saying that the double bond would be oxidized in order to form diols or vicinal glycols. Now, let us look at how this experiment of the Bayer's test can be performed. One thing that we should note is that Bayer's test can also be known as the alkaline potassium permanganate test. In this experiment, you will need some materials before you can undergo this test. We can have potassium hydroxide solution, anhydrous sodium carbonate, your sample that you want to test, your distilled water, test tubes, and a test tube holder. Before you can begin this experiment, you need to prepare your reagents. How then do you go about preparing this reagent? First of all, you need to dissolve 1 gram of potassium permanganate in 100 ml of distilled water. And this should be done in a beaker. Once your solution is prepared, add 10 grams of anhydrous sodium carbonate to that solution. Remember to shake the mixture very well. You are shaking it in order to make sure that the 10 grams of the anhydrous sodium carbonate that you added would be able to dissolve completely. Once you've been able to prepare your reagent, the next thing to do is to put a small amount of the sample that you are going to test for the organic compound in a test tube. After you have done that, you would want to dissolve this small amount in a very small amount of water, let's say 2 milliliter of water. Or you can dissolve it in acetone in a different test tube. Once your sample has been prepared, you can then add 1% of alkaline potassium permanganate solution that you prepared. And then you shake it very well. Once you shake, you notice that there will be a color change. That is, if there is indeed presence of an unsaturated organic compound. If not, the color would remain the same. One thing you should note is that this test should be done at room temperature. As a chemist in the lab, you never forget to take precautionary measures.
Aim: to identify the unsaturation present in an organic compound by Bayer's test. Step 1. Take one test tube. Step 2. Pour 0.025 grams of organic compound to test tube. Step 3. Pour 2 ml of water or alcohol-free acetone in test tube. Step 4. Add 2 ml of 1% potassium permanganate solution containing equal volume of 1% sodium carbonate solution. Step 5. The discharge of the color of more than 1 drop of potassium permanganate indicates the presence of unsaturation in organic compound.
Now, welcome back from watching the video. Were you able to follow the procedure very well? Are you now able to know the steps involved when using Bayer's test to test for or identify unsaturated organic compounds? Now let us look at the chemical reactions involved in this experiment. For alkenes, we are saying that when the sample that contains the unsaturated organic compound, in this instance, if this sample of interest contains an alkene, it is then reacted with the potassium permanganate, which has been alkaline. This should be done in the presence of water. Remember from our initial overview, we said that we are going to produce a diol. To be specific, in this instance, we are going to produce 1,2-diol. The 1,2 is referring to the position of the functional group ol. This is not the only compound that will be formed as the product. We are also going to form manganese dioxide with the formula NO2 and potassium manganate. Now let us look at the general chemical reaction for this experiment. We have the alkene on this side, the alkene, sorry, and this is our potassium permanganate. Remember, it is done in the presence of water. These are the products formed. Remember, we have said that we are going to form a diol at positions 1 and 2. Then our manganese dioxide with our potassium manganese. From our theory, that is the organic chemistry theory aspect, we said that R here represents alkyl groups. For alkynes, we are going to also test it with potassium permanganate, that is alkaline, also in the presence of water. For our product, we are going to have carboxylic acid as well as the formation of manganese dioxide. Now, this time around, the color change is going to be from pinkish purple to brown. Remember that for the alkenes, the color change would be brown. This is a general equation representing the experiment to test and identify for alkynes. This is our alkyne, our alkaline potassium permanganate, even our products carboxylic acid and manganese dioxide. Remember that the disappearance of the purple color of the potassium permanganate whilst forming a brown precipitate in its replacement are all supposed to tell you that indeed there is presence of an alkyne. This is said to be a positive Baeyer test. Positive in the sense that indeed there is presence of unsaturated compound, in this case an alkyne. Now here is a pictorial illustration to help you understand the test. So we have our test tube here. There are samples as it has been written here. Now this has already been dissolved for you. Then the potassium permanganate is being added to the solution of the sample. Note that it has been stated that it is purple colored. So once it happens, we are going to have two outcomes. The first outcome is that you would get a positive test, meaning that your color would change from purple, sorry, to brown color. That is purple to brown. The second outcome is that there is no presence of the double bond or the alkene, which would be a negative test, meaning your color would not change. I hope you get the concept now. Once you add your potassium permanganate, either there will be a color change or not. If there is a color change from purple to brown, it means that there is presence of the alkene. Once there is a color change, it means that you have positive test. The second outcome is that there would be a negative test, meaning no color change, which also means that there isn't any presence of a double bond containing compound in your sample. I hope you get the concept very well. Now, let us look at the second test, which is the bromine test. Here, the principle is that this test is able to look for the presence of these unsaturated compounds, with particular mention to alkenes and alkynes. This whole test is based on the fact that we are going to add bromine to the sample of interest, or the sample that we are going to treat. The reaction here is that the bromine is going to break the double or the triple bonds, with the bromine bonding to the carbons. When that happens, what you are going to see is that there will be a color change from brownish red to what you can say colorless, which will result in what we call decolorization. That is, change from the brownish red color to colorless is what we are terming to be decolorization. I hope you get the whole idea of this test. There are a few things that we are to note. For this kind of test, we can have the sample or the nature of the compound that we are going to test for in three forms. One, we can have the sample being water soluble. Two, the sample being water insoluble. And three, when the sample is in gaseous form. Let's go over that again. The nature of the compound here can be one, water soluble. That is, it's being able to be dissolved by water. Two, it is insoluble in water, which is water insoluble. And three, it exists in the gaseous form. These are the things that you would note going forward in terms of the bromine test. Now, each of them, or each of the nature of compounds, would have different procedure for the bromine test. But the whole idea in terms of the principle remains the same. Now, let us look at how we can prepare for our bromine test. Some of the materials that we would need are bromine water solution or bromine in chloroform. We can as well need distilled water, test tubes, and test tube holder. Now remember that the materials that you require would depend on the compound or sample that you are working on, whether it is water soluble, water insoluble, or it is in gaseous form. So how then do we prepare our reagents? Here we are looking at two reagents, bromine in chloroform or bromine water. So for bromine in chloroform or CCl4, you pour 5 ml of your liquid bromine in 100 ml of the carbon tetrachloride and you shake gently. For the other one, You take 5 ml of bromine and then you add 100 ml of distilled water. You then shake it very well, after which you will decant the clear liquid. I hope you get the difference. Very good. Now let us move on. The first compound that we are going to be looking at is water-soluble compound. That is bromine test with water-soluble compound. Here we are saying that the bromine test is most commonly used for the detection of unsaturation in organic compounds. With this one, because the compound is water soluble, we would dissolve the compound in water. Here, the overview is that, or the concept is that the bromine will readily add to your carbon-carbon double or triple bond. What are we expecting to see? We are expecting decolorization. Decolorization from which color to what? The color is going to change from reddish brown to colorless. Or you would see that the color would be from a deep red brown color to that which is lighter in terms of the color range. Once that happens, we are saying that decolorization has occurred. I hope you get the concept. Very good. The procedure that would involve in this bromine test is that when you take your unknown organic compound in the test tube, because this compound is soluble in water, you dissolve it with about 2 ml of the water. Once you have the solution, you add your bromine water. Once you are adding it in drops, you keep on shaking. Now, here we are saying that if the compound that we are looking at or the compound that we are working with contains unsaturation or unsaturated organic compound, then your decolorization happens. In other words, your color would disappear or you would have lighter color. That is, you are going to have move from deep to light color. Very good. Now let's look at the second bromine test with water insoluble compounds. Just like the name suggests, it means that such a compound wouldn't be able to be dissolved in water. The question then is, what do we need to do to such a compound? Your guess is right. We would need to dissolve in an organic solvent. The solvent that we are going to use here is carbon tetrachloride. This is used to dissolve the compound. Then we can add our bromine. What you have to also know is that we can dissolve both the bromine and the sample in the carbon tetrachloride. It follows the same principle. Bromine would add across the carbon-carbon double bond or triple bond, which again would result in decolorization from reddish brown to colorless or lighter version of the initial color. I hope it is clear. The things that we are supposed to note is that because the compound cannot dissolve in water, we have to dissolve it in an organic solvent that is suitable. Hence, we are going to use carbon tetrachloride. Here is an equation to represent the procedure or the test that we just discussed. We have an example in ethene, double bond here. Remember what we said about the addition of the bromine. It is going to break the double bond or add on to it. As you can see here, the carbon-carbon bond is now broken to form a single bond, with the bromine being attached to it. Now let's look at the color change that we discussed, from brownish red to colorless. This is just an example of one kind of unsaturated compound. You can on your own look out for different unsaturated organic compounds, either alkene or alkyne. Write the compound with the addition of bromine and then write the final product of the equation. The color change would be the same if only the test is a positive test. Now let us look at the bromine test with the third nature of compound, is the gaseous compound. Let's ask ourselves, if the compound is in the gaseous form, how will we be able to add bromine to it? Are you able to have any idea? Okay, now let us look at the concept behind this. In this instance, because we are dealing with the gaseous unsaturated compound or the gaseous sample, that sample would be bubbled through a solution of bromine. In other words, the gas would be passed through the bromine liquid. This is done in an organic solvent. Remember the organic solvent that we used in the water-insoluble compound? Yes, that is the carbon tetrachloride. This is the organic compound that would be used, carbon tetrachloride. Like we've said initially, the principle would remain the same based on the fact that addition of bromine to the double and triple bond, giving us decolorization or a color change. From which color? Red, brown, or brownish red to a colorless appearance, or from a deeper color to a lighter color. So it's whether you are looking at a water-soluble compound water-insoluble compound, or gaseous compound while testing with the bromine test, the principle remains the same. Addition of bromine to break the double and triple bond. This would be indicated by the color change or decolorization from brownish red or red brown color to colorless appearance. Now, let us watch this video to sum up the test that we have talked about in terms of the bromine test.
Aim: to identify the unsaturation present in an organic compound by bromine water test. Step 1. Take one test tube. Step 2. Pour 0.1 gram of organic compound to test tube. Step 3. Pour 2 ml of carbon tetrachloride in test tube. Step 4. Add 2% solution of bromine in test tube drop by drop with shaking. Step 5. Decolorization of bromide solution indicates the presence of unsaturation in organic compound.
Now, let us look at the two tests that we use to detect or identify the presence of unsaturated organic compounds. Are there similarities? Are there differences in how they operate or how the procedure is? Or even in terms of the reagents being used? What about the color change? Here, our comparison would be on themes. The first theme is on purpose. We are saying that for Bayer's test, mostly it is used to detect double bonds, whilst bromine test can be used to detect for both triple and double bonds. In terms of reagents, Bayer's test makes use of potassium permanganate, whilst that of the bromine test, just like the name suggests, make use of bromine as the reagent. For the color change, we are saying that all of them would undergo decolorization. That is, if it is a positive test. The difference here is in terms of which color is being decolorized. For example, for Bayer's test, we are saying that the purple color of the potassium permanganate would change to colorless, whilst for the bromine test, there will be a color change from brownish red or red brown to colorless. So in both instances, we agree that there's decolorization. However, the difference is in terms of the decolorization of the reagent. Purple to colorless for Bayer's test, brownish red to colorless for the bromine test. Another difference is in terms of the reaction products. For Bayer's test, we are saying that diols are produced, whilst for bromine test, we are looking at forming dibromo compounds. Diols for Bayer's test, dibromo compound for bromine test. Now, in terms of how specific these tests are, we are saying that Bayer's test is specific to carbon-carbon double bonds. In other words, we are saying that such makes it suitable to be able to separate or know the difference between alkenes and alkynes. The bromine test, however, does not differentiate between alkenes and alkynes. So, for example, when we do a test to identify the unsaturated compound, and then it changes from purple to colorless, then we can say that the probability that the unsaturated compound is an alkene is very high, assuming that we used Bayer's test. I hope you get the clarification now. Okay. As a way of recap, let us ask ourselves some simple questions. Can you explain what unsaturated organic compounds are? How many major tests do you think or do we need to do when we want to test for the presence of a double or a triple bond? That is the carbon-carbon bond. Are you able to name those tests? In terms of bromine test, how many forms of sample can be available? Are you able to compare the two tests, bromine test and Bayer's test, in trying to determine the presence of unsaturated compounds? If you are able to recall after this lesson, then you have done well. If not, you can go over the lecture and then fill in the gaps in terms of the concept. If you need further clarification, you can write a comment or ask questions. I'll be ready to answer you. Here are a few trial questions for you. These are some references that you can also look at. Thank you for joining our class. I hope you enjoyed the class. Let's meet again to look at another organic chemistry practical lesson. See you and take care.